Hey everyone, and welcome to The Explainer. Today, we are breaking down some truly hard data to figure out exactly when AI startups should finally ditch those serverless APIs and start self-hosting their own GPUs. Look, it's a debate literally every technical founder faces at some point. But today we actually have the receipts.
You know the old saying, we've all heard this classic piece of startup folklore. It's usually passed around as undisputed truth, right? The idea is you start out with an easy managed API, and then, as soon as your cloud bill starts getting a little too high, you buy or rent your own hardware to cut costs. But let's actually dive into this. Does that hold up in the real world? Is self-hosting inherently cheaper? Or is there some massive hidden cost cliff that you might just be walking right off of?
Well, instead of just guessing, we are looking at a massive, real-world experiment run by the team over at DigitalOcean. They took the exact same model, the exact same prompts, and ran them across 3 entirely different setups to find out exactly when that cost crossover happens. We're talking real workloads, real deployment methods, and most importantly, they measured the whole thing in actual dollars and cents. All right, let's set the stage real quick and define our 2 main contenders. In one corner, we have serverless inference. With this one, you manage absolutely nothing, zero ops. The provider handles all the GPUs, all the scaling, and you just pay strictly per token. Super simple. Then, in the other corner, we've got self-hosted GPU droplets. This is where you rent raw hardware and you take on all the operational headaches. Firewalls, drivers, containers, the whole shebang. And the kicker? You pay by the hour, whether that GPU is crunching tokens or just sitting there collecting digital dust.
But hold on, there is actually a third option in the mix here, dedicated inference. Think of this kind of like the Goldilocks middle ground. It gives you the total isolation and guaranteed capacity of a dedicated GPU, but it leaves all that annoying raw server management to the provider. So you get a fully managed endpoint, but you are still paying to keep that entire GPU warm specifically for your exclusive use.
So how do they test this? To make it a completely fair fight, they used the Q332B model, and they ran some incredibly realistic day-to-day tasks. First, a standard chat setup, which usually takes about 1,000 tokens in and spits out roughly 500. Then they tested a retrieval augmented generation, or RAG workload, which basically stuffs a massive 2,000 token document in just to get a short, precise 200 token answer out. This allowed them to meticulously track the cost, the latency, and the actual sweat equity required from an engineering team. Right out of the gate, before a single user even shows up, the provisioning speeds are just wildly different. Serverless, it's basically instant. Grab your API key and you're off to the races. Now, renting a raw self-hosted GPU takes about 4 minutes to stand up if you actually know what you're doing, but waiting for that managed dedicated endpoint takes a painful 25 minutes. And here is the real kicker from the data. You are billed for that entire warm-up time because the platform literally has to pull and load tens of gigabytes of model weights before you can even use it. Okay, but what happens when that very first user request finally hits? For a single request under a super light load, self-hosting is amazing. It clocks in at about 0.6 seconds to generate the first token. That is a full 2.5 times faster than sharing a serverless pool, which took about 1.5 seconds. When you have a totally empty private GPU all to yourself, it is incredibly snappy. But, and this is a massive catch, what happens when you scale? Having a GPU all to yourself is lightning fast for one person, but if you push a single self-hosted MI300X GPU past 32 concurrent requests, that snappy performance falls off a cliff. The overall throughput climbs, meaning the machine is physically processing more total tokens, but the wait time for individual users just starts completely falling apart. In fact, by the time you saturate that GPU at nearly 200 concurrent requests, your end-to-end latency blows past 40 seconds. That is brutal for user experience. At that point, you are forced into a really harsh trade-off. Do you want maximum throughput to get your money's worth, or do you want an acceptable speed so your users don't just close the app? Which brings us perfectly to the core financial dilemma. See, because you pay for a self-hosted GPU by the hour, whether it's working or not, the actual cost of a single answer completely depends on your duty cycle. Basically, what percentage of the day is your GPU actually sweating and working hard? And that leads us to the ultimate question, where exactly is the true price crossover? Here is the magic number the data revealed, 22%. Self-hosting only becomes cheaper than serverless when your GPU is fully saturated, running at high concurrency, and actively working for at least 22% of the entire day. But remember,
You only hit that break-even point if you are totally fine with giving your users 40-second response times just to squeeze every last drop of efficiency out of your hardware. But let's be real, you probably don't want your users waiting 40 seconds, right? If you want to keep responses relatively snappy, say around 15 seconds end to end, the math changes drastically. That break-even point jumps all the way to a 48% duty cycle. That means your hardware needs to be steadily, constantly busy for practically half the entire day just to match baseline serverless pricing. If you're running 24/7, self-hosting absolutely wins, for sure. But anything less than that, the costs creep up fast. And this right here brilliantly illustrates the devastating trap of self-hosting too early. Most early-stage startups just don't have steady, predictable traffic. They have wild spikes, which usually results in a mere 5 to 10% duty cycle on their hardware. If you are self-hosting at a 10% duty cycle and trying to keep your app snappy, it can literally be nearly 5 times more expensive, 4.8x to be exact, than just using a serverless API. Buying a GPU to save money while it sits mostly idle is just setting your cash on fire. And hey, idle time isn't the only way you lose money here either. The experiment uncovered some pretty nasty little gotchas. First, there's that near idle trap we just talked about. Second, they got hit with orphaned GPUs silently racking up massive bills. They deleted a managed endpoint, but the backing droplet stayed active in the background until they manually hunted it down. Crazy, right? Third, measuring throughput over the public internet completely bottlenecked the results, so you always have to measure directly on the box itself. And lastly, mismatched token math. You can't compare serverless prices, which usually include both input and output tokens, against a self-hosted calculation that only looks at output. You gotta line the numbers up honestly. So jumping back to that middle ground we talked about earlier, dedicated inference. If you opt for this to skip the absolute operational nightmare of firewalls, drivers, and model loading, expect it to cost about 30% more per hour than a raw self-hosted droplet. You are paying a strict premium purely for the convenience of not having to be a sysadmin. Now, with that 30% premium factored in, your new break-even duty cycle for dedicated inference gets pushed to roughly 29%, assuming you're saturating the GPU. Honestly, that is still a relatively low bar if you have predictable traffic. It makes it a highly attractive option for teams that really need isolation but absolutely do not want to be on call for hardware infrastructure at 2 a.m. So what is the final verdict here? Well, the data actually builds a perfectly actionable playbook for scaling your AI. Step 1, start your MVP on zero-ops serverless. Before you have product market fit, your traffic is totally unpredictable. Serverless handles those spikes and charges you absolutely zero when it's idle. Step 2, during your growth phase, keep most traffic on serverless, but move your most predictable, highly utilized features over to a dedicated hot path. And finally, step 3, only self-host when you achieve massive scale, with a rock-solid, steady baseload that keeps a GPU at least a quarter to half busy around the clock. At the end of the day, moving off serverless is a control decision first and a cost-saving decision second. So the next time you're tempted to go rent a GPU just because you think it's going to save you money, I challenge you to take a hard, honest look at your actual traffic patterns. Run the numbers, check that duty cycle, and ask yourself, do you really need to self-host? Or is your incredibly expensive hardware just going to be sitting around idle? Thanks so much for joining me on this explainer, and I hope this helps you optimize both your infrastructure and your budget.